Welcome to this free online course on machine learning by MT Learners. Today our topic is machine learning. So what is machine learning? In this video we will try to define what it is and also try to give you a sense of when you want to use machine learning. Even among machine learning practitioners, there isn't a well accepted definition of what is and what isn't machine learning. But let me show you a couple of examples of the ways that people have tried to define it. Here is a definition of what is machine learning as due to Arthur Samuel. Arthur Samuel, he defined machine learning as the field of study that gives computers the ability to learn without being explicitly learned. Samuel's claim to fame was that back in the 1950s, when he wrote a checkers playing program, and the amazing thing about this checkers playing program was that Arthur Samuel himself was not a very good checkers player. But what he did was, he had to program maybe tens of thousands of games against himself, and by watching what sorts of board positions tended to lead to wins and what sort of board positions tended to lead to losses, the checkers playing program learned over time and what are good board positions and what are bad board positions, and eventually learned to play checkers better than the Arthur Samuel himself was able to. This was a remarkable result. Arthur Samuel himself turns out not to be a very good checker player, but because a computer has the patience to play tens of thousands of games against himself, no human has the patience to play that many games. By doing this, a computer was able to get so much checkers playing experience that it eventually became a better checker player than Arthur himself. This is a somewhat informal definition and an older one. Here's a slightly more recent definition by Tom Mitchell. So Tom defined machine learning by saying that a well-posed learning program is defined as follows. He says a computer program is set to learn from experience E, any experience E with respect to some task T, like anything, any program, any task on which you are doing something, and some performance pair P, and the outcome of that task is P, that is made by as P. If its experience on T, like its performance on P, like its performance B on that particular task T improves with experience E, that is machine learning. I actually think he came out with this definition just to make it rhyme. For the checkers playing examples, the experience E would be the experience of having the program play tens of thousands of games itself. Like this is its experience, or like he gained something from that. The task T would be the task on playing checkers, and the performance measure P will be the probability that wins the next game of checkers against some new opponent. So that was machine learning. That was a definition of machine learning by Tom Mitchell. Let's say your email program watches your emails, you do or do not mark as spam. That is some kind of activity which you are going to do by yourself. So in an email plan like this, you might click the spam button to report some email as spam but not other emails, and based on which emails you mark as spam, say your email program learns better how to filter spam email. So what is the task T in this setting? Take a minute and guess this. So I hopefully you got the right answer. So classifying email is the task T. Like this is something to do. Classifying, that is and task T. In fact, according to the definition, there is a task T, a performance measure P, and some experience E. And so watching your label email as spam or not spam, this would be the experience E. Like that he is getting something, he is extracting something from that and getting some knowledge experience that it is spam or not. And the fraction of emails correctly classified, that is the outcome, that is the performance measure P. So that might be a performance measure P, and so on. The task of system's performance on the performance measure P will improve after some experience E, according to the definition. So in this class, I hope to teach you about various different types of learning algorithms. There are several different types of learning algorithms. The main two types are what we call supervised learning and unsupervised learning. I will define what these terms mean more in the next couple of videos. it turns out that in supervised learning, the idea is we are going to teach the computer how to do something, whereas in unsupervised learning, we are going to let it learn by itself. Don't worry if these two terms do not make sense yet. In the next videos, I am going to say exactly what these two types of learning are. You might also hear other ghost terms such as reinforcement learning and recommender systems. These are the other types of machine learning algorithms that we will talk about later. But the two most used types of learning algorithms are probably supervised learning and unsupervised learning. And I will define them in the next videos, and we will spend most of the class talking about these two types of learning algorithms. So I am actually going to spend a lot of time teaching you those sorts of best practices in machine learning and AI, and how to get the stuff to work and how the best people do it around the world. I hope to make you one of the best people in knowing how to design and build serious machine learning and AI systems. So that machine learning then there are so that's machine learning, and these were the main topics I hope to teach. In the next video, I am going to define what is supervised learning, and after that what is unsupervised learning, and also time to talk about when you would use each of them.